in about 10 raised to power 100 years, a number so large it would take you longer to read the zeros than humanity has existed. The last object in the universe will disappear. But before that, someone will witness the final sunset on Earth. The oceans will no longer sparkle. The forests will have vanished. Every city, every language, every masterpiece humanity ever created will be nothing more than memory. And yet, the universe will barely notice, because our story, remarkable as it seems, occupies less than a blink in cosmic history. The greatest events have not happened yet. Tonight, we are leaving the present behind, not by thousands, un million, but by trillions, quadrillions, and even numbers so vast that the human mind struggles to comprehend them. We will travel farther into the future than any civilization ever could, beyond the death of Earth, beyond the death of the sun, beyond the collision of galaxies, beyond the final star, until only darkness remains. And perhaps something even stranger. This is the future of the universe. The next 10,000 years. Imagine standing on Earth 10,000 years from now. If humans are still here, our world would feel almost unrecognizable. The continents continue their slow, relentless drift. Mountain ranges rise while others crumble into dust. Entire coastlines disappear beneath rising seas. Cities that once reached toward the sky lie buried beneath layers of rock. The monuments we believed eternal have become fossils. Even Mount Everest is changing. The Earth has never stopped reshaping itself. It simply moves too slowly for us to notice. But geology is only part of the story. Look up. The night sky has changed. The familiar shape of Orion is gone. The Big Dipper no longer resembles a dipper. Every star is moving through the Milky Way at incredible speeds. Given enough time, our constellations dissolve. The sky our ancestors admired exists only in ancient recordings. Meanwhile, the moon continues its silent escape. Every year, it drifts nearly 4 centimeters farther away from Earth. A tiny distance, almost impossible to notice. But over millions of years, the effect becomes enormous. The tides weaken. Earth's rotation gradually slows. Days grow longer. The rhythm of our planet quietly changes. But humanity, if it survives, may no longer be watching from Earth. Perhaps our descendants have already spread across the solar system. Gigantic cities beneath the ice of Europa. Mining colonies inside the asteroid belt. Floating habitats orbiting Saturn. Or vast artificial worlds, slowly rotating to create gravity, carrying millions of people between the stars. The Earth, once the cradle of civilization, may simply become our birthplace. But even if humanity survives every plague, every war, every asteroid, there is one enemy no civilization can outlast: time. And 4.5 billion years into its life, our sun has already started the countdown. You're about to watch a star die. The death of Earth and the sun. The sun, our constant companion for more than 4.5 billion years, has never missed a single sunrise. Every civilization, every ocean, every tree, every living creature owes its existence to this one ordinary star. But stars are not immortal, and the countdown has already begun. Deep within the sun's core, around 600 million tons of hydrogen are fused into helium. Every single second, that reaction releases an unimaginable amount of energy. The sunlight warming your face today began its journey in the sun's heart thousands of years ago. For billions of years, this delicate balance is held. Gravity pulls inward. Nuclear fusion pushes outward. Together, they keep the sun stable. But balance, never lasts forever. As billions of years pass, the sun slowly grows brighter. Not dramatically, not overnight, just a little more luminous every 100 million years. To human eyes, nothing seems different, but Earth notices. Long before the sun dies, our planet begins to change. Temperatures continue to rise. The oceans slowly evaporate. Clouds trap more heat. Water vapor escapes into space. One by one, the rivers disappear. Then, the lakes. Finally, the oceans themselves. The blue planet becomes a dry world of rock and dust. Any life that remains retreats underground or leaves Earth forever. Another billion years pass. The surface glows beneath relentless sunlight. The atmosphere becomes thin. The continents crack apart under unbearable heat. Earth, the only world known to have hosted life, is transformed into a silent desert. No forests, no oceans, no vegetation, only endless stone beneath an orange sky. But the greatest transformation is still ahead. Nearly 5 billion years from today, the sun exhausts the hydrogen fuel in its core. Without enough energy to resist gravity, the core begins to collapse. Temperatures soar. New fusion reactions ignite. The outer layers of the sun expand outward, far beyond their current size. Our peaceful yellow star becomes a red giant. From Earth, if anyone were there to witness it, the sun would dominate nearly the entire sky. Its crimson surface boils with gigantic storms, each larger than our planet. Mercury disappears first, consumed without a trace. Venus soon follows, swallowed by the expanding inferno. The fate of Earth is less certain. Some models suggest our planet will spiral into the sun, completely vaporized. Others suggest it may survive, barely, as a scorched, airless world orbiting the dying star. Either way, Earth as we know it is gone forever. Every mountain, every fossil, every city humanity ever built, every work of art, every book, every memory stored in stone, vanishes, not with an explosion, not with a warning, simply erased by the slow evolution of a star. For billions of years, our world was the center of our story. To the universe, it was only ever a tiny planet, circling an average star. Yet even as one chapter ends, another begins, because throughout the galaxy, new stars continue to ignite. While our sun grows old, vast clouds of gas collapse under gravity. Brilliant young suns burst into existence. New planets take shape. Some may already harbor oceans. Others, perhaps, are witnessing the first sparks of life. The universe has no favorites. As one world dies, countless others are born. Our sun may become a graveyard, but the galaxy it belongs to is falling towards something far bigger. 1 trillion stars, racing toward us at 100 kilometers every second. It's already happening. We just haven't reached it yet. When galaxies collide, past the frozen edge of the solar system, beyond the billions of stars that make up the Milky Way. From this distance, our entire galaxy becomes a single glowing spiral, one of hundreds of billions scattered across the observable universe. It feels permanent, unchanging, but even galaxies are travelers, and ours is speeding toward another giant. More than 2.5 million light-years away lies our nearest large galactic neighbor, Andromeda. For millions of years, it has appeared as nothing more than a faint smudge in Earth's night sky, almost invisible, but appearances can be deceiving. Andromeda contains roughly 1 trillion stars, stretching over 200,000 light-years across. Its gravity reaches far beyond what the eye can see, and every second is racing toward us at more than 100 kilometers per second. The collision has already begun. We just haven't reached it yet. For billion years from now, the night sky starts to change. Andromeda grows larger, brighter. Its graceful spiral arms begin to fill the heavens. For millions of years, future observers would witness the greatest celestial display in history. A galaxy slowly consuming the sky. Then, the impossible happens. The two giants meet, not with a deafening crash, but with an elegant dance directed by gravity. Their spiral arms stretch like ribbons across space. Immense streams of stars are pulled outward, forming glowing bridges hundreds of thousands of light years long. Gas clouds collide. Shock waves race through the darkness. Across both galaxies, new stars ignite by the billions. The universe briefly shines brighter as fresh stellar nurseries are born. Surprisingly, almost no stars actually collide. The distances between them are simply too vast. If our sun were the size of a grain of sand, the nearest star would still be hundreds of kilometers away. Galaxies appear crowded. In reality, they're mostly empty space. The greatest force at work is not collision, but gravity, slowly, patiently, reshaping everything. Over the next 2 billion years, the Milky Way and Andromeda spiral together. Their beautiful disk shapes disappear. The graceful arms that once stretched across hundreds of thousands of light years are erased. In their place, a new galaxy is born. Astronomers sometimes call it Milkomeda, a colossal elliptical galaxy, home to trillions of stars. And at its center, something even more extraordinary. Hidden in the hearts of both galaxies are supermassive black holes. Each contains millions, or even billions, of times the mass of our sun. As the galaxies merge, these cosmic giants begin their own slow dance. They orbit one another for millions of years. Each pass brings them closer, until finally, they collide. The merger releases an unimaginable burst of gravitational waves, ripples in space-time, that race across the universe at the speed of light. Then, silence. Where there were once two monsters, only one remains. A single supermassive black hole, larger than either before, patiently waiting for the next stars to wander too close. If intelligent life still exists, its night sky will be unlike anything humanity has ever known. No familiar constellations. No Milky Way stretching overhead. Instead, one immense galaxy filled with brilliant clusters, glowing nebulae, and ancient stars. To them, this merged galaxy won't seem unusual. It will simply be home, just as the Milky Way once was to us. But galaxies, like stars, also grow old. The clouds of gas that once fueled new suns are slowly running out. One by one, the stellar nurseries fall silent. The universe begins to lose its light. For trillions of years, the smallest stars will keep burning long after giants like our sun are gone. They'll become the last lights in the universe. And when even they go dark, the age of stars ends forever. The last light, the merged galaxy, slowly rotates in silence. Its brilliant spiral arms, gone. The explosive birth of new stars has almost completely ceased. The universe has entered a quieter age, not because time has stopped, but because the fuel that once lit the cosmos is running out. For trillions of years, the brightest stars disappear first. Massive blue stars, which once lived fast and died young, are long gone. Stars like our sun have already exhausted their fuel. Some have become white dwarfs. Others have collapsed into neutron stars. The universe grows older and darker. Yet, a few stars refuse to surrender. Scattered throughout the galaxies, tiny red dwarf stars continue to shine. They are small, cool, almost insignificant compared to giants like the sun. But appearances can be deceiving. Unlike larger stars, red dwarfs burn their fuel with incredible efficiency. Some are expected to live for up to 10 trillion years. that is nearly 1,000 times longer than the sun's lifetime, long after every familiar star has vanished. These faint crimson lights still glow. If life survives this far into the future, it may gather around these ancient suns, their warmth, their final refuge, in a universe growing steadily colder. Imagine looking into the night sky. 10 trillion years from now, there are no bright blue stars, no colorful nebulae, no newborn solar systems, only a handful of dim red lights, scattered across an ocean of darkness. The age of abundance is over. Every sunrise has become precious. Then, one by one, even the red dwarfs begin to fade. Some quietly cool into black dwarfs. Others end their lives in rare explosions. The process is unimaginably slow. A cosmic farewell, lasting trillions upon trillions of years, until finally, the last star burns out. No sunrise follows. No new light appears. For the first time since the universe was young, there are no stars left. The stelliferous era, the age of stars, has come to an end. Darkness now dominates the cosmos, but it is not empty. Ghosts of the stellar age remain. Cold white dwarfs, silent neutron stars, frozen planets wandering through interstellar space. And everywhere, black holes, some no larger than a city, others more massive than billions of suns. These ancient giants have become the rulers of the universe. They drift through the darkness, occasionally swallowing a passing star or stellar remnant. Each meal releases a brief flash of radiation, a fleeting reminder of a universe that was once filled with light. Even galaxies themselves begin to disappear, not because they are destroyed, but because the universe continues to expand. Driven by dark energy, space stretches faster and faster. Distant galaxies slip beyond the cosmic horizon. Their light can never reach us again. Future civilizations, if any remain, may believe their galaxy is the only one that ever existed. The evidence of the Big Bang, the countless galaxies, the vast cosmic web, will have vanished beyond reach. The universe will seem small, lonely, almost empty. And yet, the greatest monsters in existence still endure. Black holes. For unimaginable lengths of time, they remain almost unchanged, patient, silent, waiting. But even they cannot escape forever, because the universe has one final surprise. A discovery made by physicist Stephen Hawking revealed that black holes are not completely black. They slowly lose energy, so slowly that a supermassive black hole may survive for around 10 rays to power 100 years. A number so vast that writing it out would fill entire pages with zeros. But even eternity has limits. The kings of the cosmos won't rule forever either. Even black holes are dying, just too slowly for anything alive to notice. And when the last one disappears, the universe enters a chapter with no stars, no galaxies, no light. Only silence and time. We're almost at the end of everything. After the last black hole, no stars, no galaxies, no glowing nebulae, only a single black hole, floating through an endless ocean of darkness. It has outlived everything. Every civilization, every planet, every star, even the galaxies that once surrounded it, are gone. For a time, it seems as though this giant will remain forever. But the universe still has one final story to tell. In 1974, physicist Stephen Hawking made a remarkable prediction. According to quantum physics, black holes are not entirely black. Tiny quantum effects near their edges allow them to lose energy extremely slowly. This process is now known as Hawking radiation. For a black hole the mass of our sun, the journey to complete evaporation would take around 10 rays to power 67 years. For the supermassive black holes once found at the centers of galaxies, the wait is vastly longer, on the order of 10 rays to power 100 years. Numbers this large are difficult to imagine. If every second since the Big Bang were represented by a single grain of sand, you still wouldn't come close. Compared to these timescales, the entire history of humanity is less than the blink of an eye. Across this unimaginable span of time, the black hole shrinks, not dramatically, not even noticeably, but relentlessly, year after year, age after age. It gives away tiny amounts of energy, until finally, after a lifetime beyond comprehension, the last black hole reaches its end. In a brief burst of radiation, it vanishes. The final giant is gone. For the first time since the birth of the universe, there are no stars, no planets, no black holes, no galaxies, only a thin sea of low-energy particles, drifting farther apart as space itself continues to expand. This possible future is known as the heat death of the universe. Not because everything becomes hot, but because energy is spread so evenly that nothing meaningful can happen anymore. No new stars ignite, no worlds form, no chemistry unfolds, no structure remains. The cosmos approaches a state of maximum entropy. A universe that has reached complete thermodynamic equilibrium is a place of profound stillness. Or is it? Science is remarkably successful at explaining what we observe. But when we look this far into the future, certainty begins to fade. Some ideas remain active areas of research. If protons, the building blocks of atoms, are ultimately unstable, then over immense timescales, even ordinary matter could gradually disappear. So far, however, no experiment has confirmed proton decay. Other hypotheses suggest that quantum fluctuations may continue to occur, even in an almost empty universe. And some cosmological models imagine that entirely new regions of space-time could emerge under the right conditions. These possibilities are fascinating, but they remain speculative. At the edge of time, our knowledge gives way to questions. Perhaps the universe ends in silence. Or perhaps what appears to be an ending is only another beginning. Throughout cosmic history, every ending has led to something new. The death of stars created the elements that form planets. The collapse of ancient gas clouds gave birth to new suns. The explosion of long-dead stars made life possible on Earth. Maybe creation and destruction have always been two halves of the same story. Now, return to the present. Look up at the night sky. Every star you see is living through an extraordinary moment in cosmic history. You exist during the age of stars, a brief era when galaxies shine, planets are warm, and life can ask questions about the universe that created it. Out of billions of years, and perhaps trillions still to come, this is the chapter in which we find ourselves. Not at the beginning, not the end, but in the rare moment when the universe is filled with light. One day, the last star will fade, the last black hole will vanish, and the cosmos may fall silent. But today, the universe is still writing its story, and so are we. The future is not a destination. It's the longest story ever told, and we've only just begun to read the first page. If you enjoyed this journey across the future of the cosmos, subscribe to The Years Ahead, because the next story may be even more unbelievable.